This is chapter number 7. Alternating current. Also known as AC. See, we have two types of sources of magnetic field. One sources of current basically. One is the DC source. The DC source is basically your cell or battery. We used DC source from chapter number 3 to chapter number 4. In chapter number 3, we solve all circuits using cell. So that was DC source. Even in magnetics, for the current carrying wire, the current was DC current. But apart from cell or battery, you have another source, which is a dynamo generator. That is an AC source. So that is alternating current, AC current. So we have two types of current basically. One is DC current, which is known as direct current. Another is AC current. AC, alternating current. Alternating current. So let's see what the difference between the DC current and the AC current. In DC current, both the magnitude and direction of current are constant. Both magnitude and direction of current are constant. That's DC current. For DC current, both the magnitude as well as the direction of the current are constant in DC current. Source is a cell. Is cell or battery. The source of DC current. When you draw current versus time graph is a straight line. Current versus time graph for a DC current is a straight line. In alternating current, both magnitude and direction of current change periodically. Both magnitude and direction of current change periodically. So both the magnitude as well as direction of current will change. Its source is AC dynamo or generator that we call in normal language. If I draw current versus time graph, then from the graph you can see both the magnitude and direction are changing. The graph is this. Both the magnitude of current and the direction of current are changing continuously. But here, both magnitude and direction of current are constant. I versus T graph is a straight line. This is a variable. This is changing continuously. Symbol of DC source is this. DC source is this. This is the symbol of a DC source. And this is the symbol of AC source. Symbol of AC source. Basically, the dynamo is this. This is how we represent a AC source. So till now we have used DC source. We know how to apply Ohm's law for a DC source, how to calculate voltage for a DC source. Now you have to learn like how to solve an AC source, how to calculate current through an AC source, how to apply Ohm's law to a AC source. Just note it down. Just tell me once you have written. Huh?
Done, sir.
Okay. Fatima, noted.
Yes, sir.
So that's AC source. Huh? So first we will start this chapter with.
Sir, can you scroll up? Okay, sir.
The next is AC dynamo. We have already discussed the principle of AC dynamo while we were doing motional EMF, but I'm repeating that thing again. An AC dynamo consists of, just let me show you an animation. See how you generate EMF in an AC dynamo. Do you remember Faraday's law? Noor, what is Faraday's law?
So when flux linked with the coil changes and EMF is induced in the coil.
Very good. Fatma, this is the expression of flux, right? BA cos theta. In how many ways you can change the flux linked with the coil?
The theta can be changed, area can be changed, magnetic field.
Can be changed. Good. So we can change flux in 3 ways: by changing theta, by changing B, and by changing A. In an AC dynamo or an AC generator, we change flux by changing theta. Basically, what we do, we rotate coil in the magnetic field. Due to rotation of the coil, the angle between the magnetic field and area vector change. And due to the change in that angle, flux change, and you get induced EMF. So I'm just showing you a small animation on AC dynamo. Just 1 second. See, this is an AC dynamo. An AC dynamo consists of, this is the structure of an AC dynamo. AC dynamo consists of 2 magnetic poles, north pole and another is south pole. In between these 2 poles, you have this is north pole and this is south pole. In between 2 poles, you have this frame, this rectangular frame. Over the frame, you have turns of coil. Some turns of coil are wound over it. So what happened is when you rotate this coil, see when this frame is in this way, the area vector is upwards. Magnetic field is to the right hand side. So angle between magnetic field and area vector is 90 degrees. Your area vector is magnetic field is to the right hand side and area vector is upwards. See what happens when it rotates. This is armature. This is shaft through which you rotate this coil. This armature rotates means coil will rotate. Coil is wound over the armature. When coil rotates, the flux, the angle between the magnetic field and the coil will change. Due to change in that angle, this is slip rings. EMF generate, and through these slip rings, that EMF transfers to the, these are brushes, and this EMF get transferred to the circuit. So this is the complete circuit. So you're rotating this armature. Due to rotation of armature, the angle between magnetic field and area vector is changing. Due to change in that angle, flux will change. Due to change in flux, EMF get induced into it. And that EMF, that voltage, that induced current travels from the coil to your device through these slip rings and carbon brushes. This is how it travels. This is a simple AC diagram. Just one second. So this is AC Dynamo. This is how it works. The principle and the construction, I will share a PDF file for principle. Principle is Faraday's law of electromagnetic induction. It works on the principle of Faraday's law of electromagnetic induction. Construction, this I will send you as a PDF. This is basically the construction. It have two magnets, armature rotating in between the magnets. See theory. Here B is strength of magnetic field. B is strength of magnetic field. A is area of coil. N are the number of turns. Theta is angle between magnetic field and area vector. Sania, we just have started this topic. This is we have started chapter number 7 just now. So the first topic in chapter number 7 is AC Dynamo. AC Dynamo, AC generator. That was also in class 10 syllabus. We are discussing that one. So AC Dynamo, AC generator consists of two magnetic poles. In between these magnetic poles, one armature is rotating. So here B is the strength of magnetic field. The magnetic field generated by these two poles, the strength is B. A is area of coil. The area of this armature is A. N are the number of turns in the coil, and theta is the angle between magnetic field and area vector. So you can write that magnetic flux phi is NBA cos theta. That's magnetic flux phi, which is NBA cos theta. Where N are the number of turns in the coil, B is the strength of magnetic field, A is area of coil, and theta is the angle between them. Now, there's one more thing, which is angular velocity. Okay. Angular velocity or frequency of the coil. Angular velocity means velocity with which this coil is rotating. Angular velocity with which this coil is rotating. Or you can say the frequency with which this coil is rotating. Frequency means number of rotations completed in 1 second. That's omega. Yes, does anyone remember any relation between angular velocity and angular displacement? Haji.
Omega is equal to theta by t.
Yes, angular velocity is angular displacement divided by time. So this is equation number 1. So you can say that angular displacement is angular velocity divided by time. That's equation number 2. Now what we can do is we can just substitute 2 in 1. We have already did this calculation in electromagnetic induction. I'm just repeating it again. This is NBA. Yes, Abdullah.
That theta is angular displacement.
Angle and angular displacement is the same thing here.
Okay.
In mechanics, we call this as angular displacement, which is basically an angle, nothing but an angle. Okay. So this is it, NBA cos theta. This is the flux linked with this coil, which is rotating in between these two magnets. Amalia, is this flux constant or variable? Amalia, is it a constant flux or a variable flux? Okay, how you decide whether this flux is variable? Yeah, very good. This flux depends upon time. So it's not a constant flux, it's a variable flux. So now if we have a variable flux, then how would you calculate induced EMF, Fatma? Fatma, we have flux, variable flux. How would you calculate induced EMF in coil? Okay. Mariam, if you have a flux which is changing, how you calculate induced EMF? Yes, Noor is correct. If Faraday's law of electromagnetic induction, if your flux is changing, then induced EMF is minus of d phi over dt. So it's minus of, it's d over dt of phi. What is phi? Phi is NBA cos omega t. Yes, minus of d phi over dt. So there n, b and a are constant. You can take them outside. This is d over dt of cos omega t. And I need derivative of cos omega t. So when I differentiate cos omega t, I get minus of sine omega t. The derivative of cos is minus sine. But along with t, you have one constant omega here. So this constant omega will come outside. This is basically known as chain rule. So you get EMF is NBA omega sine omega t. This is induced EMF NBA omega sine omega t. So this is the EMF induced in the coil of this generator. And this is what you experience in your home. The EMF, the voltage coming from the power plug is basically this EMF. This EMF. This is the equation of that EMF. The EMF that you are getting at your home is due to rotation of some coil in magnetic field. That happens in a power plant. In a hydroelectric power plant, to rotate this coil, we use water. In a thermal power plant, to rotate this coil, we use thermal energy. In a nuclear power plant, to rotate this coil, we use nuclear energy. That's the only difference. But in all power plants, this is the coil which is rotating, and due to rotating of this coil, you get magnetic. You get induced EMF. Note it down. So Sania, is this EMF constant or it's a variable EMF? Sania, you can use your mic, bache.
Sir, it's variable
How you know that this is variable?
because it's depend on time.
Very good, because it depends upon time. So it changes with time. And it depends upon time through a sine function. Okay, if I ask you to calculate maximum value of EMF, Fatma, can you guess the value of sine omega t if the maximum value of sine omega t? What should be the value of sine omega t for maximum EMF? Okay, Fatma, how much is sine 30? Fatma. Mariam, how much is sine 30, Mariam?
1/2.
And what is the maximum value of sine? You know, value of sine 0, sine
1 to
90.
1.
Maximum value is 1. Minus 1 is the minimum. Maximum value is 1. So the maximum value of sine omega t is 1. So for maximum value of EMF, your sine omega t should be maximum and this is plus 1. When you substitute this plus 1 here, you get that maximum EMF. I represent maximum EMF as E naught also will be NBA omega multiplied by 1. Equation number 4. And so this maximum EMF comes out to be NBA omega. That's equation number 5. Next, what we can do is we can substitute 5 in 4. When we substitute 5 in 4, we get E is E naught sine omega t. So this is E. E is E naught sine omega t. So this is the equation of EMF. This is equation of AC EMF. So this is the EMF that you are getting from this generator or from this dynamo. If you want to plot this EMF versus time graph, this is time and this is EMF, this will be the shape of the graph. This maximum value of EMF is E naught. This is the maximum value of EMF that is E naught. Note it down. This much you have written. This is the equation of EMF. Yes, written.
Yes, sir.
So this is your source in AC. This is your EMF in AC. Like when we were doing DC, we used to give source in this way, like we used to draw, this is the cell, this is cell of 10 volt, right? When we do AC, we draw it like here. This is the source and EMF is E naught sine omega t. You will not get a constant value here because AC EMF is not constant. It changes with time. It changes periodically with time. At some time, its value is 0. Then it becomes maximum. Then it becomes 0 again. Then it becomes negative. Negative means the polarity have shifted. This is minus of E naught. And this is 0 again. So that's the difference between DC and AC. DC is constant, but AC change periodically, it change continuously. So till now we solve circuit using this type of source. Now we will solve circuit using this thing. What is omega here? Amalia, what is omega?
Angular velocity.
Angular velocity or angular frequency. See, what was angular frequency means? Angular frequency of the coil it was. Now we will say this is the angular frequency of the AC current. Means the frequency with which your AC change is omega. So now we will start with equation of AC EMF. Equation of AC EMF. So the chapter starts from here. This is the first equation. E is E naught sine omega t. From where this equation came? It came from AC Dynamo. Now let's see each and every value. What is omega? Omega is angular frequency of AC current term. You can write your omega as 2 pi nu, where nu is linear frequency of AC. Nu is linear frequency of AC. The SI unit of omega is radian per second. The SI unit of linear frequency is hertz. And this is the relation between them. What is E naught here? E naught is the peak value of EMF. What is E here? E is the RMS value of EMF. The RMS value of EMF is E. So this is it. E is E naught sine omega t. E naught is the peak value. E is the RMS value. Omega is the angular frequency. And nu is the frequency. Note it down. We'll do one question on this equation only. Oh, sorry, E is not the RMS value. Instantaneous value. Instantaneous value of E. Note it down. Noted? Sania? Okay. Do this question. This is the equation of AC EMF. E is 20 sine 314 t volt. This is the equation of EMF. Calculate first peak value. See this peak value, or this is also known as maximum value. This is also known as amplitude of current. Note it down. So all are the same things. You can write peak value, maximum value, everything. So that's the peak value of EMF, maximum value of EMF, or amplitude of current. So first calculate peak value. Second, calculate angular frequency. Then calculate linear frequency. Next, calculate, you have peak value, you have angular frequency, you have linear frequency. And then you need EMF at t equal to 2 seconds. Do it now. Do it and write your answer in chat. I need answer of each one of you.
So there's sine 340, sine 314.
Sine 314. You can write 314 as 3.14 into 100, right? You can write 314 as 100 pi.
Okay.
Answers. It's not that lengthy. Sania, Fatma. Fatma, are you solving it?
Yes, sir.
Good. Yes, Noor. First is correct. Shahzada.
Yes,
Shahzada,
sir.
this is straightforward thing here. This is straightforward. Huh? Just have to compare it with this equation. Just compare it with this equation. E naught sine omega t, 20 sine 314t. Instead of E naught, you are using something. Instead of omega, you are using something. Just keep writing the values. Abdullah, first part is correct. Second part is correct. Third part is also correct. Noor, yes, second is also correct. Mariam, at least write answer for the first part. Nah? See, if you can't solve it, just compare this equation with this equation. And keep on writing the values of E naught. Keep writing the values of omega. If you know omega, then you can calculate frequency from here. Good, Fatma. First is correct. Sania, Mariam, and Shahzada, and Amalia. Very good, Noor. Third is also correct. Fatma, second is correct. Good. Yes, Abdullah. Right. Mariam, no answer. See, Sania, this is the standard equation of EMF. See, this is E naught. Yes, Mariam, this is correct now. E naught sine 314t. Sania, this is the standard equation, E naught sine omega t.
Yes, sir.
And this is the equation that I have written, 20 sine 314t. Instead of E naught, what are you using? 20. So E naught
Yes,
is.
sir.
Instead of omega, what you are using? Sania. Yes, Samia. Instead of this omega, which term are we using here? Just compare. So instead of omega, you're using 314 here.
314. Yes,
So
sir.
your omega is 314, angular frequency is 314. The unit is radian per second, is 314 radian per second. Third part is asking about linear frequency. Omega is 2 by nu. So you can write your nu as omega over 2 pi. So how much is omega? Omega is 314
314.
divided by 2 pi is your frequency. So it's 314 divided by 2. How much is pi? Pi is 3.1.
3.14.
So when you divide them, see 314 divided by 3.14. When you cancel them out, it's 100. Frequency comes out to be 50 hertz. So this is the frequency, 50 hertz frequency. Okay. Okay, Fatma.
Yes, sir.
Yes, sir.
After frequency, the fourth part is you need value of current at t equal to 2 seconds. You can do one thing. Instead of this t, put t equal to 2 seconds. This is the equation. Huh? E is 20 sine 314 t. 314 t. You need EMF at t equal to 2 seconds. Put t equal to t here. So E is equal to 20 sine 314 into 2. 20 sine, it's 628. Don't worry about size sine 628. All these values would be given. If you want, you can convert it in terms of pi, but you can leave it here only. These values are usually given in the question. So this is how we use this equation. This is the equation of Ac Emf. So Ahmed, you are very late today.
Sorry, sir.
So we have started this thing, emotionally, this chapter number 7. So we have finished AC Dynamo. We start with this equation. See, in AC, the equation of EMF is this, E naught sine omega t. This is the equation of EMF in AC, E naught sine omega t. Here, E naught is the maximum value of EMF. Omega is the frequency with which the EMF is changing. And this E is known as the instantaneous value. Like when I give this equation numerical, E is 20 sine 314 t volt. You're supposed to calculate peak value, angular frequency, linear frequency, and EMF. That's the first equation of AC. So E is E naught sine omega t, E is 20 sine 314 t. When you compare them, instead of E naught, you are using 20. Instead of omega, you are using 314. So you can write E naught as 20, omega as 314. Once you have omega, you can calculate frequency. It's omega by 2 pi. The next part, he asks you to calculate EMF at t equal to 2 seconds. So in this equation, here, instead of 2, just substitute t equal to 2. Note it down.
Yes, sir, clear.
Note it down. Amalia, is it clear now?
Yes, sir.
Done, sir.
So AC EMF, Sania, is it constant or it's variable?
It's variable.
Variable. So when a term change, then we calculate various types of averages. So see first what different type of average we can calculate. So this is EMF versus time graph. This is 0. This time is t by 2. And this time is capital T. This is t by 4 time. And this is known as 3t by 4. So this 0 to t is the time taken by AC by the coil to complete one rotation. This t by 2 is the time taken by the coil to complete half rotation. So this is known as first cycle of AC. And this is what we call second cycle. Or you can say this is half cycle. And this whole is first cycle. one cycle, one complete cycle. This is half cycle of AC. This is the half cycle. So up to here, you have first half cycle of AC. Okay, so next. We will calculate average value of AC for full cycle. AC EMF, huh? We are still calculating AC EMF, then we'll calculate AC current for full cycle. Full cycle means for which time? 0 to T. Means for the time period when coil complete one rotation. Okay, if I ask you to calculate average of 2 and 3, how will you calculate average of 2 and 3?
2 plus 3 divided by 2.
We'll add them up and divide it by 2. This is how we calculate average of 2 and 3. What if I ask you to calculate average of 2 and minus 2? Fatma, what would be the average of 2 and minus 2? Fatma, I'm just asking average, how we calculate average. No answer from Fatma. Nazira, how we calculate average of 2 and minus 2? Nazira, are you in class? Just calculate the average of 2 and minus 2, Nazira. How we calculate average? We add them up and divide it by the number of quantities. So what will the value if you add 2 and minus 2? Yes, so what should be the average? It's 0. If you calculate average of 2 and minus 2, it comes out to be 0. So when you calculate average of two quantities which have equal positive and negative value, then you get 0. Similarly, if you calculate average of instantaneous current, we calculate average value in this way. This is the average for the full cycle. This is symbol of average. See, this is a AC EMF. AC EMF is this. E is E naught sine omega t. If I ask you to calculate average of E, then we write average of E in this way. You can write this as average of E as E naught sine omega t naught. This is the symbol of average. E naught is constant. You can take this constant outside and you are left with the average of sine omega t. Now let's see how to calculate the average of sine omega t. Average of sine omega t is the sum of maximum value of sine omega t. Sania, what is the maximum value of sine theta? Nazira will tell. Nazira, what's the maximum value of sine theta?
1.
1 plus 1. Very good. And Nazira, what's the minimum value?
0.
Not 0.
No.
Minus 1.
Yes.
So plus 1 minus 1 divided by 2. How much is it? 0. So average value of sine omega t is 0. Average is 0. So when we do these substitutions, we get average value of EMF. We get average value of EMF to be 0. So average value of induced EMF is 0 now. So for the complete cycle, the average value of EMF is 0. You can predict this 0 value from this graph also. It have equal amount of positive and negative values. So when you add them up, it gets cancelled out. Just note it down. But remember, this is average for full cycle. But if we calculate average for half cycle, then it won't be 0. Yes, note it down. Note it down. Next, we will calculate the average value for half cycle.
Yes, sir. Done.
Done. Okay. So what do you think? If you look at this half cycle, this 0 to t by 2, what do you think? Average value should be 0 or it should be non-zero? It could be non-zero. What do you think?
It could
Yes,
be 0.
could be 0. From 0 to t by 2, EMF is positive only or it have negative values also? From 0 to t by 2.
A positive value.
Positive.
Positive value. There is no chance it gets cancelled out. Huh? It can get cancelled out only if have both positive as well as negative value. But if it don't have any negative value, then it can't get cancelled out, right?
Yes, sir.
So if you calculate average value for half cycle, then it won't be 0. Average value of AC EMF for half cycle. So to calculate average value for half cycle, what we do is I represent average value for half cycle with EM, or you can write E average. That's the same thing. When we write E average, we means half cycle. Half cycle means in time 0 to t by 2. Although derivations are not a part of the syllabus, but I'm writing the complete thing. So it's 0 to t by 2. You will integrate EMF. Like you will integrate E naught sine omega t dt from 0 to t by 2. Then you will divide it by t by 2. When you solve it, the whole, and you can take this E naught outside the integral. So you can write this as 0 se t by 2. It's sine omega t dt divided by its t by 2. This whole term, this whole integral comes out to be 2 by pi. So you can write that average value of EMF, this whole integral, this thing comes out to be 2 by pi. So it comes out to be E naught into 2 by pi now. So you can write this as E naught into 2 by 3.14. When you divide 2 and 3.14, you get 0.637 of E naught. So you can say that mean value or average value for the half cycle is it's 2 by pi E naught, or it's 0.637 of E naught. These values are very, very important. So if you're calculating for the full cycle, it comes out to be 0. But if you're calculating for the half cycle, then it comes out to be 2 by pi. Note it down. And those who have maths must have done integration till now. Huh?
No, sir, we didn't start.
Okay, that's simple integral. When you do integration, the simple integral. It's not a part of syllabus. That's why I'm not solving it right. Noor, just to get the average. See, in average, we add quantities and divide it by the number of quantities. But when we have function, instead of addition, we do integration. This integration is for, it substitute addition for numbers. And for dividing by the number of quantities means you will divide it by the limit that you, or over which you are integrating.
Okay,
So
sir.
addition, instead of addition, we are using integration. And in denominator, we write the number of quantities. Instead of number of quantities, we write the limit. Written?
Yes, sir.
Okay. See, next, RMS value. RMS value of AC. So to calculate, see what is RMS means. RMS means root mean square. RMS means root mean square value. So if I give, so first of all, see this thing, how we calculate RMS. Like if I give you some numbers like I1, I2, I3, and I ask you to calculate RMS mean. So first of all, what we will do is we write this as root mean square, but operation is in the reverse order. So what we do, we first take square. So we first take I1 square, I2 square, I3 square. We first take square, then we take mean. For mean, just add them up and divide it by 3, then take root. This is how we calculate RMS value. So for RMS, first take square, then take mean, and then finally take their roots. This is how we calculate RMS. So we need RMS value of AC EMF, root mean square value of AC. So for IRMS, this is method when you have individual values. But when you have function, like if you have function of EMF in this way is E naught sine omega t. For RMS, we write this as in this way. ERMS is first take square. It's E naught square sine square omega t. First take square. Then take mean. This is the sign of mean. Then take root. See, this is E naught square. It's a constant. You can take it outside. It's root over E naught square. Next, we need mean of sine square omega t. Let's call this as equation number 1. So for mean of sine square omega t, just like the previous one, when we take mean of sine omega t, we take its maximum value, we take its minimum value, add them up and divide it by 2. Just tell me, what is the maximum value of sine square omega t? Maximum value of sine?
1.
1.
Okay. Does sine square can have any negative value? Is it possible that sine square have a negative value?
No, sir.
No,
Yes,
sir.
No, sir.
Square, even if it have negative value, it gets squared. So what should be the minimum value of sine square omega t? It can't
1.
be -1. What is the
0.
maximum value?
0.
0. It can't be -1. Why it can't be -1, Amalia? Amalia,
Because
why?
it gets squared.
Squared, so there would be no negative value. So, Nazira, what's the minimum value of sine square omega t?
1.
1 is minimum. Then what's the maximum?
Maximum.
What's the minimum value?
Equal to 0.
0. 0 divided by 2. So
Sir,
that,
1 is maximum or 0?
just tell me. +1 and 0, which could be the maximum value?
Okay, it's 1.
1 is maximum, 0 is minimum. So it's half. So next, what you can do is you can put 2 in 1. When you put 2 in 1, you get ERMS as its root over its E naught square. You can write sine square omega t is half. ERMS is root over E naught square by 2. Next, what you can do is E naught you can take outside, divided by root 2. 1 by root 2 is 0.707. So this is the RMS value of E. This is how we calculate RMS value. There's one more method through integration, but this is an easier one. Do it square, take E naught square outside. Just calculate average of sine square. Average is maximum value plus minimum value divided by 2. That's it. Note it down. In the same way, we'll calculate all these values of current also. Shahzada, where were you?
Yes, sir.
Yes, where were you?
I got some work, that's why. I left the meeting for 10 minutes.
Shahzada, those 10 minutes were very, very crucial. Like you missed the whole starting of the chapter. Okay, just note it down. I will tell you. Mhm. Okay, Ahmed. All right. So what you will do? We'll discontinue the meeting.
Maybe work with my old one.
Hmm. Sure, okay, okay, Ahmed. No issues. So these are the different values of AC EMF. So how many values we have studied till now for EMF? The maximum value, the instantaneous value, the average value for the full cycle, the average value for the half cycle, and the RMS value. You should remember all these values of EMF. Similarly, you will get these values for current also. Noted? Nazira?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, so let's do this thing. Solve this question. It's a very straight formula based thing. Abdullah, any issue in it?
No, sir.
Equation of AC EMF is, this is the equation of AC EMF. Huh? E is 10 sine 314 T volt. This is the equation of EMF. Calculate first part. Try to calculate first of all the RMS peak value. Get the peak value. Second, angular frequency. Third, frequency. Fourth, peak value, angular frequency, frequency. Then you can have average value for half cycle. Then you have average value for full cycle. Then last, I need RMS value. Do it and write your answer in chat. Good, Fatma. First part is correct. Very good. First is correct. Second is correct. Third is correct, Abdullah. Fourth is correct. What about the fifth one? Fifth is correct. Sixth is correct. Okay, good. Noor, first is correct. Nazira, first is correct. Noor, second is correct. Fatima, second is correct. Sania, first, second, third, all are correct. Noor, third is also correct. This is formula based thing. Like Nazira, your answers. Amalia, Mariam, answers. Yes, Noor. Fourth and fifth are correct. Yes, Mariam. First part is correct. Third is also correct, Fatma. Good. Yes, Noor. Sixth is also correct. No, Sania, you don't need instantaneous value. You need average value. Yes, Nazira, third is also correct. Mariam, second is correct. Fatima, fourth is correct, right? Second is correct, Nazira. Fatima, fifth and sixth are also correct. Shahzada, look at these calculations. See, this is straightforward. This is 10 sine 314 t volt. Compare it with the standard equation. This is the standard equation. E naught sine omega t volt. Amalia, first, second, third, all are correct. Shahzada, just tell me, just compare these two equations. What is here instead of E naught?
10.
10. So E naught peak, this E naught is known as peak value, maximum value. That's 10 volt. What is instead of omega? Yes, Shahzada. Instead of omega, what you're getting here?
So 314.
314. So this is your omega, 314 radian per second. Third, what you have here instead of no, so you have omega. From omega, you can calculate omega is 2 pi nu. So you can write that nu is it's omega over 2 pi. What's the value of omega?
Value of omega.
Omega is 314, right?
Yeah, yeah.
This is 2 pi is 3.14. So when you divide them, it's 100. It's 100 by 2, 50. So nu is 50 hertz. Fourth one. So nu is 50 hertz. After frequency, the next thing is average value. Huh? See, average value for half cycle, this we represent it by EM, and this is 0.637 into E naught. That's the average value for the half cycle. So how much is E naught, Shahzada?
0.637.
E naught,
10 volt, 10 volt.
10 volt. Multiply them. What's the answer?
6.37.
Volt. Fifth one. For the full cycle, na, when you calculate average for the full cycle, Sania, how much is average for the full cycle? Yes, Sania. Average
Yeah.
value for the full cycle.
0.
0 is the average value for the full cycle. When you take part 6. RMS value, huh? ERMS. ERMS is 0.707 into E naught. How much is E naught, Shahzada?
So 10.
Multiply them. What's the answer?
7.07.
This is how we calculate average value for half cycle, average value full cycle, and RMS value. Is it clear, Shahzada?
Yes, sir.
Did you write the question?
Yes, sir.
Okay, just note it down.
So
Write the solution.
what's the SI unit of E0 or EMF?
It's EMF. EMF is volt always. Voltage. It's a EMF. Similarly, we can have these values for current also, but let's Shahzada finish this thing first. Shahzada, tell me once you have written. Huh?
Yes, sir. That 4, 5, 6. Okay.
It's okay.
So done.
It's okay. So just like the values of EMF, you can have values for current. Like we can have equation of AC current. Abdullah, can you guess the equation of AC current?
Yes, sir.
Yes, Abdullah. What's the equation of AC current? Just like EMF, it's I naught sine omega t, right? Instead of EMF, you will use current. The rest of the terms have similar meaning. What should be I naught here, Abdullah?
Peak value of current.
Peak value of current. And what is I?
Instantaneous value of current.
And what is omega?
Angular frequency.
Very good. Next is average value for full cycle. Full cycle. Similar result. Shahzada, do you remember average value for full cycle of EMF? No. For full cycle, average value is always 0. I'm just copy paste the result. Just copy paste the results of the EMF. EMF and current have same results exactly. Same type of calculations. Instead of E, just write I here, and the whole of the calculations will get repeated. So I'm not repeating the entire calculation. I'm just writing the final results. Average value for half cycle. Nazira, what should be the average value for half cycle of AC current?
Average value of half cycle is
Yes, yes.
0.637.
Good. 0.637 of I. See, AC is a comparatively easier topic. If you are not afraid of trigonometry, average value, not average value is over. Next, I need RMS value. Sania, what should be the RMS value of AC current? Sania, you know the average value of EMF. Can you write the average value of current also?
0
RMS value, sorry, not average. RMS value.
+1 minus.
What was ERMS? Sania, ERMS, bache. This was ERMS. E naught by root
E naught
2.707. E naught, na?
Yes, sir.
So what should be IRMS?
I naught
Over root 2
root 2.
0.707 of I naught, right?
Fine. Yes, sir.
This is IRMS. So just like EMF, you have current also. Just note it down. Shahzada, are you getting it?
Yes, sir.
See the logic behind this thing, you know. AC is a variable current. It changes continuously. So when a thing change, we prefer to calculate various types of averages. So we're calculating 3 types of averages. Averages for full cycle, average for half cycle, and RMS. RMS is also a type of average. Basically statistics, nothing else. Next, we will solve circuits. Circuits having resistor with AC current. We'll see how circuit behaves for AC. In chapter number 3, we did circuits with DC. Now we'll do circuits with AC. Yes, can I scroll it?
Yes, sir.
Yes, sir.
Sure. It's okay. The next topic is phasor and phasor diagram. See what are phasor quantities. Phasor is a general term for all quantities which change sinusoidally with time. Means those variable quantities which have sine or cos in their equation have a very particular type of variation which is known as phasor. So phasors are quantities which varies sinusoidally with time. When we say sinusoidally with time, we means these quantities either have sine or they have cos in their equations. So this quantity could be either written as E is E naught sine omega t. See, these are few examples of phasors. Sine omega t. Or you can write this as E is equal to E naught sine omega t plus phi. This is also a phasor. Or you can write you have current which is I naught sine omega t minus phi. All these are examples of phasors. Not just sine, you can even have cos in their equations like I naught cos omega t. This is also an example of phasor. So phasors are those quantities which have either sine or cosine in their equations. In phasors, one term is very important, and that is the argument of sine term. When I say argument, that means angle. Here, omega t is the argument. Here, omega t plus phi is the argument. Here, omega t minus phi is the argument. Here again, omega t is the argument. This argument is known as phase. So this is the phase. This is the phase. This is phase. This is the phase. For an phasor, phase is like the soul of this equation. Like how this EMF will change with time depends upon this phase. This phase controls the time dependency of EMF or current, or in general any phasor. Like for phasors, we are not just restricted to EMF and current. You can have velocities, you can have displacements, you can have accelerations, you can have kinetic energy, which depends upon sine and cosine functions. But right now, we will concentrate only on EMF and current. But phasors could be any quantity which depends sine or cos in their equation, like a velocity. A velocity of this type, like if I write V is V naught cos omega t, it's also a phasor. S is equal to S naught sine omega t is also a phasor. Quantity which change sinusoidally with time are known as phasors. Okay, after phasors, this is phase. So Abdullah, what do you think? These first three quantities have same phase or different phase? First three quantities, Abdullah, they have exactly same phases or their phases are different?
Different. Yes.
Different phases. Huh? Here phase is omega t, here phase is omega t plus phi, here
Yes.
phase is omega t minus phi. Dude, phi is just any angle. Phi could be any angle, 30 degree, 40 degree, pi by 4, pi by 6, any angle is phi. I'm just trying to change the phase. So another example, like we have E is E naught sine omega t, and I have another equation which is I naught sine omega t plus pi by 2. Sania, this EMF and current have same phase or they have different phases? Just look at the phases.
Different phase.
So what's the difference in the phases of these two equations?
Pi by 2.
Pi by 2. Very good. So this difference is we call phase difference. So they have phase difference between E and I is pi by 2. Sometimes we represent phase difference by phi. So phase difference is pi by 2. I can write this as phi is pi by 2. Phase difference is pi by 2. Phase difference is just an angle. Difference in phases. Let's take another example. I take I is I naught sine omega t plus pi by 2. And I take E is E naught sine omega t plus pi by 4. So Ahmed, these two equations have same phase or they have different phases?
Different phases.
Can you
No.
calculate phase difference between them?
So it is
Mhm.
actually
Mhm.
no, they
Yes.
are not same,
How much?
but they will meet at the same point. Like after one circle,
I'm just asking about the difference in their phases, nothing else. You
pi
said
by
that phases are not how much? Pi by?
pi by 2 and pi by 4.
Nah.
That's the difference. The
Difference
difference
could be
is pi
one,
by 2.
not pi by. Abdullah, what's the phase difference?
Pi by 4.
Just subtract their phases.
Pi
Take
by
omega t plus pi by 2 and subtract omega t plus pi by 4 from here. So omega t will cancel this omega t. Pi by 2 minus pi by 4. You are left with pi by 4. Right?
yes, clear.
When you see, I'm writing other steps also, all steps. So this is omega t plus pi by 2 minus omega t minus pi by 4. So see, omega t will cancel this omega t. If you subtract pi by 2 and pi by 4, you will get pi by 4. So phase difference phi here is pi by 480. So this is how we calculate phase difference. Just by looking at the equations, you can decide what's the phase difference between them. Just note it down. Then we'll see how we draw phasor diagram. Just tell me once you have written. Okay, the next is phasor diagram. Before starting phasor diagram, just tell me one more thing. I'm giving you two phasors. Fatma, just look at these two phasors, sine omega t, and you have another E naught sine omega t plus pi by 2. So Fatma, what do you think? These two have same faces or different faces? Fatma, different faces. Okay. Which Okay, can you tell me, Fatma, which one have greater phase? Like the current or the EMF one? EMF. So can I say that EMF leads current? EMF have a greater phase, right? By what angle EMF is leading current? Pi by 2. So this is how we decide lead or lag. Let's take another example. I'm writing I is I naught sine omega t. And I write E is E naught sine omega t minus pi by 2. Okay, now Nazira will tell. Nazira, these two have same faces or different faces?
Different.
Different. So which one have greater phase?
I.
I. So E have less phase than I, right?
Yes.
So can you tell me which one lags?
E.
E. By what angle?
By pi by 2.
So I can write this as EMF lags current by pi by 2. Okay, can I write this if I'm writing that EMF is leading current in this case? Can I write that current lags by EMF by pi by 2? The same thing? If I'm writing that EMF is ahead of current by pi by 2, and I can similarly write that current is behind EMF by pi by 2. I can write that current lags by EMF by pi by 2. These two statements are same. Either you say that EMF is ahead of current, or you say that current is behind EMF, the same thing. So here you say EMF lags by current by pi by 2, or you say that current leads EMF by pi by 2. That's the same thing. Current leads EMF by pi by 2. Okay, just note it down. So this is a very common terminology that we use in AC: lead and lag. Current leads EMF, EMF leads current. So leads and lags are in terms of phases only. Note it down. Then we'll see what is phasor diagram. Yes, noted.
Yes, sir.
Yes, sir.
Next we will do phasor diagram. See what does phasor diagram means. Phasor diagram. Phasor diagram is basically a diagram which shows phases of individual quantities very clearly. That diagram will show which quantity is leading, which quantity lags. So to draw phasor diagram, we use following step. Very easy thing. To draw phasor diagram, take arrow having length equal to peak value, having length equal to peak value. the inclination of that arrow with respect to x-axis is basically the face angle which this arrow makes with x-axis is equal to face of the arrow. This is how we draw phasor diagram. So for example, if I call you to ask you to draw the phasor diagram of this thing I naught sine omega t. So take this thing. This is x-axis, this is y-axis. Take an arrow, the length of the arrow is equal to y naught. This is an arrow, its length is equal to y naught. With x-axis, see the face is omega t, take this as omega t. While drawing this phasor diagram, we consider this omega t as an acute angle. Huh? This is acute. This is acute. So we take it to be acute angle. Let's take another example. If I ask you to draw phasor diagram of I naught sine omega t plus pi by 2. Okay. So now you will take an arrow, the length is equal to I naught, but now the angle is not omega t, angle is omega t plus pi by 2. So it would be here. If this was omega t, this is omega t plus pi by 2. This would be here. If this is omega t, right? This is omega t. And this is pi by 2 plus omega t. So it will go in this quadrant. If I ask you to draw phasor diagram of this term, I naught sine omega t minus pi by 2. See, this dotted line is omega t. Okay, this is my reference omega t. Saying omega t minus pi by 2 means it will go in this direction. It will go down. This is I naught. So for drawing phasor diagram, we just take an arrow. The length of the arrow is equal to I naught. Obviously, the value of I naught is not given. So you won't measure the length. You will take an arrow and write to I naught over it. This arrow will make some angle with the x-axis. That angle is equal to the face. So if face is omega t, you will write it as omega t. If face is omega t plus pi by 2, you will take omega t plus pi by 2 and all. Omega t minus pi by 2, you will write it as this. Okay, just note it down. Yes. I need 5 to 6 more classes to finish this topic. So if October 1st week, we'll finish it.
So can you move up? Okay, sir.
Yes, sir.
Okay, so that was about phasor diagram. There's one more thing in phasor diagram, and that is see y projection gives instantaneous velocity. Y projection always gives instantaneous velocity. Like in this phasor diagram, if you take y projection, this is the y projection, and this y projection will give instantaneous velocity I here. This is y projection. Y projection means just take a perpendicular on the y-axis. This will give instantaneous velocity. Also here, take projection on y-axis. That's instantaneous velocity. So wherever you have y projection, that y projection will give instantaneous velocity. Just note it down. Just drop a perpendicular on y-axis. That perpendicular will give you this. So this is the basic structure of alternating current. Like you should know what are the different types of average values and instantaneous values, and this phasor and phasor diagram. You will hardly get any question from these topics, but these are the foundations. All other things that we will do in in AC alternating current will depend on these foundations. So next we will start with circuits. We'll start with AC circuits. Means circuit having AC as a source. So we'll have many circuits like AC circuit. The first circuit is AC having resistor. AC circuit having resistor. That's the first circuit. AC circuit having resistor only. AC circuit having inductor only. AC having capacitor only. Okay, so let's stop here. We'll continue this in the next class.
Okay, sir.
And please start revision, like revision from chapter number 1 to chapter number 3 at least.
Yes, sir.
Okay, sir.
Yes, sir.
Okay.
Thank you, sir.
Thank you,
Thank
sir.
you, sir.
Lovely.
Yeah.
Thank you, sir.